Welcome everybody. I'm here together with David Brook. He's Director Sales and Marketing from ICC Embedded, and we will be talking about developing embedded middleware for safety environments. Hello David.
Hello, thank you for inviting me.
Welcome. David, what are the trends currently in the market for verifiable software?
Well, we have been developing embedded middleware components in ICC for 12 years, and we've seen in the last few years a trend towards verifiable software. There are new regulations and new types of applications in different markets, and we've been working very hard to try and match those trends in the marketplace.
When do you really call a software verifiable?
Well, that is an excellent question. In our opinion, it's a considerable effort to develop a process that can establish verifiable software. Much embedded software in an environment of safety or an environment which requires certification or validation is treated as unknown. And that puts the responsibility on the application developer to test and verify someone else's software in his application. But in ICC, we want to take responsibility for our software, and we've developed a concept called AEM, which we call Advanced Embedded Middleware. And contained within that concept is our software development process. And in order to achieve the goal of verifiable software, we take the whole software management lifecycle. We apply a V-model process to development, and that means that we define and manage every step in the process, from requirements all the way through to implementation and test. And more importantly than just following that process, we document it and we make that available for our customers so that they can understand and verify how we developed our software, and they can then blend that into their application development. It's a very complex process.
Okay.
One of the examples of that software is the way in which we've implemented our embedded TCP/IP stack, which is widely used in a number of different markets.
So which are the most important markets for such kind of software?
Well, we see significant demand from embedded developers who are developing industrial control and automation applications. For example, these could be applications like remote sensors or gas detection devices. They could be in industrial plant control or power generation. We also see the introduction of TCP/IP as a network in vehicles because of its flexibility and its capability to handle high capacity. We very importantly see the introduction of verifiable software in portable and handheld medical applications, which now widely use embedded controllers, whereas maybe in the last 5 years that's not been the case. Mm-hmm. So across a fairly broad range of markets. TCP/IP is one of a couple of examples I can give of how that software is applied. There are many embedded TCP/IP stacks available on the market. It's a technology which has been around for a long time. However, we've found that embedded developers, and in particularly quality managers and people who handle safety, tell us that C is not an appropriate language, for example, for development of safe applications. And one of the practical steps that we've taken to address that is to use the well-known MISRA standard to develop our embedded TCP/IP stack. And MISRA can be very rigorously applied. There are many ways to apply MISRA in C development, but we've taken a fairly strong view of that. And what we've done in applying MISRA and applying almost every rule in almost every situation is we have created a subset of the C language which is very strongly typed and is really appropriate for use in safe applications. We've also applied, as another example, our safe software to the medical domain. We have an application called DICOM, which is used for handling medical images in hospitals. And as I'm sure you'll understand, having your medical examination, if you have an X-ray or an MRI, and your patient data verifiably combined and stored and transmitted to the hospital server is quite an important thing to achieve for applications.
Sure, I can understand that.
And this example that we have here describes a common system in a hospital where patient information is stored on one server, and then where there may be a medical professional with a portable application. This could be any kind of medical application, normally which would have an image, maybe an X-ray of your knee, or some scan, for example, of the retina of your eye. And our software allows you to safely and verifiably combine the patient data and the examination information, and then transmit that using some of our embedded software components, like fail-safe file systems or certified TCP/IP stacks, with the goal, first and foremost, to have a safe application that you can trust. But of course, as a secondary validation of that, customers have to take their software to the FDA or to the European authorities to be certified, and they have to provide all of the evidence to prove that they've developed a safe, reliable application.
Is there anything common, any common requirements for all the application markets, different application markets in the embedded industry?
Yes, we see a common software development process which we can apply in different markets and to different applications. So in HCC, we've developed a common process and methodology for embedded application software. It starts with and includes all of the components listed here, from measure compliance. We fully model all of our software using UML and generate requirements and test specifications. So we implement a full V-model development process. And what that allows us to do is then take what's relevant in each different market, whether this is industrial control or automotive or medical, and then we can apply the appropriate standards in each market. So while it's very difficult to build that process, once we have that approach to software development, then we can then apply that in each relevant market.
Thank you very much.
Thank you very much.